All right, so this is one. If you did subtract your 1 and you tried to rewrite the middle term, 3 times 1 is 3. Are there any factors of 3 whose sum is negative 24? It's not going to work. So that means that your solutions are going to have irrational numbers in them. And so you either solve this by completing the square or quadratic formula. It asks you in this section to use completing the square. So my first step is to move my constant alone, which is already done. My second step is to get my leading coefficient to be a 1. So what do I divide every term by? 3. That gives me x squared minus 8x, leave a space, is equal to 1/3. Okay, and so now when I complete the square here, I'm going to take half of my b, my first degree term's coefficient, which is negative 4, and square it. Negative 4 is 16. Now, instead of adding 16 on this side, I'm going to add 16 in terms of thirds. Okay, so 16 is how many thirds? And does it make sense that 48 thirds is the same thing as what's written in red here, 16? I simply put it in the same denominator here. And what that allows me to do is I write my left side as the binomial square, which is part of our pattern. And on the right side, when I combine these, I get 49 thirds. I'm then going to extract my square root. I get x minus 4 is equal to, always take into consideration the positive and negative root. The square root of 49 is 7 over the square root of 3. Well, dividing by root 3 is just like multiplying by root 3 and dividing by 3, right? Or you can rationalize the denominator. So when I add my 4 to both sides, plus or minus, I get 7 root 3 over 3. And then the final step would be to write 4 in terms of the same fraction. So here I could have done it here as well. Adding 4 is like adding how many thirds? 12. So you get 12 plus or minus 7 root 3 all over 3